Welcome everyone. So far we have discussed about various ingredients of concrete. In the unit 1, we have discussed about the different ingredients of concrete, and in the unit 2, we have discussed about the adding one more ingredient, that is the fifth ingredient as admixtures. Because in the conventional concrete, we will be adding only cement, fine aggregate, coarse aggregate, and water. In addition to these four ingredients, we will be adding one more ingredient, that is admixtures. It may be a mineral admixture or it may be a chemical admixtures. And the reason for adding this admixture is to increase some of the properties of the concrete. It may be in the point of strength, or it may be the resistance to the corrosion, or sometimes that admixtures will be capable of reducing the freezing and thawing effect, and so on. So the reason for adding admixture is to get some good properties in the concrete. Usually there will be some disadvantages in making concrete. So some of the desirable properties, undesirable properties can be overcome by addition of these admixtures. So there are various kind of admixtures we all know already. So there are mineral admixtures, which is also known as pozzolanic admixtures. Means those mineral admixtures will be in pozzolanic in nature. And in addition to that, you will be adding one more called chemical admixtures. We have discussed about these in the previous sessions itself. Now we are going to discuss about the air entraining admixtures. Okay, so what is mean by air entraining admixtures means we are going to incorporate some amount of air into the concrete because of its benefits. Because of adding this small quantity of air into the concrete, we will be getting some of the benefits in the concrete. So we have already told, right, admixtures of capable of increasing some of the good properties in the concrete. For that purpose, here we are going to discuss about the air entraining admixtures. So basically, there are two kinds of air in concrete. One is entrapped air and another one is entrained air. Okay, entrapped air means usually when you're making concrete, there will be some air voids present in the concrete. What happens? This air void is not at all good for the concrete. For that purpose, we will be compacting the concrete using some tamping rod. If you are making in the lab means we will be using the tamping rod. Inside we can see either they will be using one stick or they will be using the rod while placing the concrete, because that will reduce the air voids present in the concrete, because the air voids will not be in any uniform shape. The shape of the air voids present in the concrete will be irregular. This is called entrapped air. What happens? This entrapped air, okay, they may be interconnected inside the concrete. Okay, so you think, uh, let me explain. Just think like this. Oh, so here this is your concrete section means, see, this is your concrete, just imagine this is your concrete surface. You will be having some entrapped air like this. Okay, here will be there, here will be there. It will be dispersed through the concrete surface. They may be interconnected. Okay, you can see here, here they are very close. They may be interconnected. So what happens whenever this concrete surface is exposed to some environment, like if the environmental is exposed to some chemical attack, or if the concrete is placed in an underwater construction, this water or chemical will be easily penetrated using this pores, because these pores are interconnected. Okay, since these pores are interconnected, what happens? The water or the chemicals will be, chemicals means they are not good for the concrete. They may cause sulfate attack, chloride attack, alkali aggregate reaction in the concrete. These are all not very good effect in the concrete. Okay, so it will make the concrete get affected. So we have to reduce this entrapped air. This entrapped air is not at all good for concrete. For that purpose, we will be doing compaction. This and all we all know very well. Okay, so then you will be thinking, then why we are adding this entrained admixtures, which means we are incorporating some amount of air in the concrete. Now also take on concrete surface. Okay, now you think here you will be having what happens in this air entrained admixtures, these pores will be placed uniformly. Okay, so this diagram may not be clear, but you should understand the spores will be uniformly dispersed and the size of the pores will also be uniform. There is no difference in the size of the pores or uniform dispersion. Okay, there will be only uniform dispersion of the air voids in the concrete using this air entraining admixtures. What happens? Again, imagine this concrete surface is prone to some chemical attack area or some water prone zone. So what happens whenever that water or chemical is attacking the concrete? So now also here you are having some air voids, but they are not interconnected. Okay, here there is no any interconnection. So there is the possibility of reducing the permeability. So the water cannot penetrate into the concrete easily. This is one of the advantages. Okay, with respect to this, we will be discussing lot more points in the air entraining admixtures. Okay, this is called this is the difference between the entrained and entrapped air. Okay, so entrained air is good for concrete. To use this entrained air, we are adding one more admixture that is called air entraining admixtures. Okay, so we are clear about that. Next, those entrained air will be, we all know the size may be vary from 5 micron to 80 micron because they are not in the same size, they may be varying. Next, we are going to discuss about the uh, air entraining agents. Okay, okay. There are some of the air entraining agents are there for making air entrained concrete. Okay, so whenever you need that air entraining concrete, you will be adding the air entraining admixtures. To make that air entraining admixtures, there are some of the agents are there. They may be a natural material or they may be the artificial material. Mostly they will be getting from the natural agents. Some such a things are natural wood resins, animal and vegetable fat and oil such as tallow, olive oil and their fatty acids, and stearic and oleic acids. Okay, some of the vegetable fats and some of the acids where they are using as a air entraining agents. In addition to this, they are also using some alkali salts. Okay, that is sulfated or sulfonated organic compounds and water soluble soaps of the resin acids, and some of the miscellaneous material means it may be the sodium salts of any petroleum products like sulfonic acids, hydrogen peroxide and aluminum powder. These are all some of the air entraining agents. These are all not air entraining admixtures. There is difference between air entraining agents and air entraining admixtures. Okay, we are now discussing only about the air entraining admixtures. These are all the air entraining admixtures. Okay. Next, we are going to discuss about the factors that are affecting the amount of air entrainment. This is very important point. Okay, here we are having many things. Okay, so I think here we are having 8 points. Okay, so let us discuss one by one. First, we are going to discuss about the factors affecting the amount of air entrainment. In that, we are having 8 different points. One is the type and the quantity of the air entraining agent, water cement ratio of the concrete mix, the grading of the aggregate and the type of aggregate you are going to use in the air entraining admixtures, its mixing time, temperature of the environment in which you are going to use this air entrained concrete, and the type of cement. And so we already told about compaction, so it also influenced the air entrainment, so we are going to discuss about that also. And finally we are going to discuss admixtures that are other than air entraining agent. Okay, air entraining admixture is also one of the admixtures. In addition to this, you may be adding some more admixtures. Okay, if needed you will be adding some more admixtures. So we are going to discuss whether it causes anything or not in the concrete. First, coming to the type and quantity of air entraining agent. Okay, we very well know that there are different air entraining agents are there. Okay, so what happens, there will be at the same time there are different quantities of air entraining agents we may add. Okay, quantity may differ. you may add some amount of air entraining agent in the concrete. Sometimes you will be using higher amount of the air entraining agents. This will influence in the result of the concrete. This is also one of the important point because mm, this amount of air entrainment depending on the elasticity of the film of the bubble formed. Bubble means that air bubble will be formed, right? Over that there will be some film, one layer will be forming, that is called a film. So this will influence the elasticity. Okay, so the surface tension in the concrete will get reduced. Can you understand? So whenever you are incorporating some air in the concrete, what happens? There will be some air bubbles, right? Over the air bubble, there will be one thin layer will be formed. Due to this thin layer, surface tension in the concrete will get reduced. So the amount of, if there is more air bubbles means there will be lesser surface tension. If I am using only lesser air bubbles means what happens? The surface tension will be little higher when compared to the previous case. So depending on, that is what they are meaning. Depending on the quantity, that is the amount of air bubbles, that is how the amount of air bubbles is attained, that just by the use of amount of air entraining agents. Okay, so the quantity of air entraining agents depends upon the amount of air bubbles. Okay, so that is also one of the important point. Next we are going to discuss about the water cement ratio. For water cement ratio we are considering on three different cases. Okay, one is low water cement ratio, intermediate water cement ratio, and a higher water cement ratio. So whenever you are adding a low water cement ratio to the concrete mix that is subjected with the air entraining admixtures, what happens? The slump value will be not high. Slump value means how to say, whenever you are using low water cement ratio, there will be a lesser amount of air voids. Okay, so if you are adding some intermediate water cement ratio, that is in the second case, intermediate means somewhat in the range of zero point 0.4 to zero point 0.6. Okay, water cement ratio will be in the range of zero point zero point 0.5 like that. Okay, so if you are adding somewhat in the range of zero point 0.4 to zero point 0.6 means what happens? There will be little bit increase in the amount of air bubbles in the concrete. So when you are using higher water cement ratio, there will be more amount of air bubbles present in the concrete. Okay, so the large amount of air entrainment is produced when you are adding higher water cement ratio. This large proportion of the air bubbles, what happens? This will get lost over some time. Okay, so the quantity of air increased from the lowest finest modulus to the highest finest modulus of 2.5. This is also important. So whenever you are adding higher water cement ratio, what happens? Air bubbles will be more. This air bubbles is capable of getting lost over some time. This is also one of the factor affecting the amount of air entrainment in the concrete. Next, we are going to discuss about the gradation. Uniform gradation should be carried out because it influences the quantity of the air entrainment. So, grading of aggregate should be ensured while mixing in the while making that air entrained concrete. Next, we are going to discuss about the mixing time. Okay, so what they are telling is the amount of air entrainment is found to increase with the mixing time up to certain time, and after that the prolonged mixing will reduce the air entrainment. Can you understand? So you are making concrete, right? So you will be adding all the ingredients together and you will be mixing together. While mixing, if you in addition to the concrete making materials, you will be adding some amount of air entraining admixtures. So this causes some air entrainment in the concrete. We all know very well. So what happens when you keep on mixing that mix over some time? The air bubbles present in the concrete will get reduced over some time. So the mixing time is also influencing the amount of air entrainment in the concrete. Okay. Next, coming to the temperature. So temperature also shows some significant effect in the amount of air entrainment. If the temperature of the concrete increases means, temperature of the concrete means The temperature of the environment. Okay, the temperature of the environment increases means the amount of air entrainment will get reduced. Okay, this is also one of the important point. Next we are going to discuss about the types of cement compaction. Oh, compaction, you know very well. If you're compacting the concrete for more time means what happens, surely the air bubbles will get reduced. This is just similar to the mixing time. When you keep on mixing the mix for long time, the air bubbles will get reduced. Similarly, when you are compacting, the air bubbles will also get reduced. Okay, so the other admixtures, you will be using some other admixtures in addition with this air entraining admixtures, right? This will also surely affect the amount of air entrainment. If you are using fly ash, okay, you know fly ash is one of the mineral admixtures. Since it is pozzolanic in nature, you will be adding to improve the shrinkage properties in the concrete, right? If you are using this fly ash in concrete, it will reduce the amount of air entrainment. Okay, so you are having some more chemical admixtures also there, like calcium chloride. If you add some amount of calcium chloride to the air entrained concrete, it will also reduce the tendency. It will also reduce and limit the amount of air entrainment in the concrete. So this is also some of the admixtures, or if you add some of the admixtures to the concrete, it will greatly influence the amount of air entrainment in the air entraining concrete. Okay, next we are going to discuss about the effect of air entrainment on the properties of the concrete. Okay, so here we are having so many properties. First, majorly we are having three properties. One is increased resistance to freezing and thawing, improvement in workability, and finally we are having reduction in the strength. Okay, let us discuss one by one. Okay, resistance to freezing and thawing. We all very well know what is meant by freezing and thawing effect. See, if you are having in India, we don't have such a temperature. Whenever you are going from some northern regions, what happens? The temperature will be greatly changing. Greatly changing means they will be having the temperature below freezing point. Okay, there will be temperature below 0 degree Celsius. At that time, if you are having on concrete surface, we all know whatever you do, concrete is the conventional concrete is capable of creating crack. Okay, so now we have found some smart concretes like self-healing concrete, self-curing concrete and all. Okay, the self-healing concrete will be capable of arresting the cracks. These are some of the smart concretes. That is, these are some of the special concretes we have found nowadays. But when we are discussing about the conventional concrete, there will be surely some cracks in the concrete. Okay, so you imagine there is one crack in the concrete. Just let me show one image. See, this is a pavement. Here there is some crack. Okay, so what happens? The air. So here you are having the crack. This crack will be filled by some amount of water. So here what is happening to the temperature? The temperature is getting below the freezing point. Below the freezing point means it is capable of making the water in this crack into ice. Okay, it is capable of making the water into ice since the temperature is below the freezing point. So what happens? Again the temperature will, when again the temperature increases, this concrete, this crack, what to say, this ice will get melted and it again forms like a water. So there will be the alternate temperature variation. This is the first thing. And whenever water is becoming ice, what happens? You also know one more thing. The volume of ice is 10% higher than the volume of water. Okay, so the volume occupied by the water will be increased when it is changed into ice. It will be increased by 10%. So what happens? The crack may increase. The crack level will also increase. To arrest this effect, they are using air entraining admixtures. Now you may also ask how this mechanism will help. Let me explain. So here you can see one. Wait. Here you can see this is some of the cracks. Okay, this black shaded, no, this. So this is under some of the cracks in the concrete surface. This is the concrete surface. This black region, black background is the concrete surface. Here you can see some white dots like this and all, right? These white dots and all nothing but it is the air bubbles present in the concrete due to the incorporation of air entraining admixtures. Okay, see, you can see they are uniform in size and they are distributed properly. Now what is happening? Here you are having some cracks, right? So this cracks will exert some pressure due to the presence of ice. Okay, due to the presence of ice, what happened? The volume will get increased. If the volume is getting increased, the pressure will be exerted. So think this is just think like that. This is your small area. Here I am going to fill some. Just imagine this is one small room. If I am filling the room with 10 students, it will be easy for them to stand. So in the same small room, imagine I am just putting 50 students together. What happens? It will be under pressure. The students can't stand there. Okay, they will be attaching over the surface of the wall. What happens? They are applying the pressure over the wall. Similarly, when the volume of the water is getting increased, which means the volume, since the water become ice, the volume of this crack will be increasing due to the pressure exerted by the ice. Okay, this pressure should be avoided. For that purpose, what is happening? This here you can see in the third image that pressure is exerted to the air bubbles present in the concrete, nearer air bubbles. See, this is the crack area. Here you can see, okay, the pressure is exerted to the air bubbles. See, it is exerted here, and also it is exerted in the hole. So other places are free from the pressure. So it does not affect the concrete now. Okay, this is how this mechanism works. This is how the freezing and thawing effect works. Okay, is it clear? Next, we are going to discuss about the workability of the concrete in the air entrained concrete. Okay, due to the addition of this air entraining admixtures. Okay, this also affects this amount of air entrainment will surely affect the workability nature of the concrete. We all know what is meant by workability. It is the easy or how to say, it is the ease of work. How easily you are going to place the concrete. That is the workability of the concrete. Okay, so they have found that placing the air entrained concrete having a slump value of 7.5 centimeter is easy to that of non-entrained concrete. Non-entrained concrete means some conventional concrete whose slump value is 12.5 centimeter. Can you understand? The slump value is getting reduced when you are adding air entrained concrete. Okay, so they are considering two concrete. One is air entrained concrete. That is, we are incorporating some air entraining admixtures whose slump value will be 7.5 centimeter. Okay, on another side, they are taking one more concrete, that is conventional concrete. In conventional concrete, you will not be adding any admixtures and all. Okay, so that is producing a slump of 12.5 centimeter. So this reduced slump value in the air entrained concrete will make the concrete to place easily. Okay, if the concrete is placed easily, what happens? It results in homogeneous mix of the concrete. Okay, it shows they are homogeneously mixed together. Okay, they are binded together. All the ingredients are acting as an integral part. They are binded together. So it reduces the segregation, bleeding and honeycombing formation in the concrete. And also the concrete containing this entrained air is more plastic. Okay, it is more plastic, so that only it is a standing stiff. Okay, so that only the slump value of this air entrained concrete is little higher than the conventional concrete, right? So the entrained concrete is more plastic, so it can be easily handled when compared to the ordinary concrete. Okay, and also due to this improvement in the workability, okay, due to some improvement in the workability because of this air entrainment, some of the things also we should consider here. Okay, one is when you are proportioning the concrete mixes. Okay, proportioning the concrete mixes means you will be proportioning the concrete, like how much cement you need, how much of fine aggregate, coarse aggregate and all, right? So there you will be discussing about some points. One is workability and another aspect is strength, durability, volume stability and all. Okay. So whenever you need workability, what happens? The strength will get reduced. Whenever you need strength, the workability will get affected. So you have to make some compromise between these two. We all know very well about these two. Okay, so workability requires the interparticular voids in the aggregate to be more than filled by cement paste. If you need, see, there will be some air voids in the concrete, right? So if you need very workable concrete means that voids in the present in the aggregates should be filled by the cement paste, so that only it will be easy for you to place the concrete. Okay, so but this air entrained concrete, now what happens? The entrained air increases the effect of volume of the cement paste during mixing and placing. It is increasing the percentage of the, it is increasing the volume of the cement paste. Thereby, it also eliminates the extra cement paste that is to induce the workability. Having fulfilled the requirement of workability for placing and compaction, the extra air will escape or it may made to escape to achieve desired density in the hardened concrete. See, in entrained concrete, see in conventional concrete, what happens? There will be some amount of air voids that can be filled by the cement paste to get desired workability. Okay. Similarly, in air entrained concrete, what happens? You will be getting more amount of air voids, so you'll be requiring more amount of cement paste, right? So, and also one more thing you should note here, when you're satisfying the workability criteria for placing and compacting, you will be making the extra air present in the concrete to evacuated, which means you will be vanishing that extra air present in the concrete. This may happen due to the process of compaction. Okay, this can be done by compaction. So as a result, what happens? 1/2 to 2/3 of the air content in the fresh concrete will be driven out depending on the time of duration. Okay, depending on the time of duration and water cement ratio. So this improvement in the workability of the air entrained concrete can be also be used for the lubricating effect of the microscopic bubbles between the fine aggregate, and it also provides some cushioning effect between the grains of the sand. Okay, therefore it reduces the particle interference to be minimum. Okay, next what we are going to discuss is about strength. Okay, coming to the point of strength, there is you may see the word reduction as a negative point, because reduction in strength means how can we adopt this concrete, like, and all will be thinking. But you imagine you are placing some concrete in some northern region. Okay, so I have told that the temperature will be below the freezing point. In that zone and all, you have to prefer this concrete, because there will be freezing and thawing effect. This will surely make the concrete structure deteriorated into pieces. Okay, so for that purpose only we are using this. That is major purpose. Next, coming to the reduction in strength, how does it affect? Okay, let us discuss. The air entrained concrete means there will be more amount of air bubbles in the concrete. Whenever there are more amount of air bubbles, the density of the concrete will be lesser. So obviously the compressive strength of the concrete will get reduced. We are all very clear about this though. So the compressive strength of the concrete will get reduced. But on the other side, we should be clear about one more thing. The amount of cement paste required by this air entraining admixtures will be little higher. Okay, little higher due to the water cement ratio we are adopting for this concrete. So what happens? There may be some of the possibilities. Okay, so the cement paste content will get increased, but the sand, that is the fine aggregate content, which is a fill-in material, that content will get reduced. Due to these properties, the reduction in strength will not be such a big variation. Okay, there will be only a slight variation. Sometimes it may be equal to the conventional concrete also. Okay, so this can be we don't want to doubt whether we can use this air entrained concrete in the normal zone. Okay, so it can be used in the construction also. Next, in addition to this, you will be discussing about some of the points like segregation, bleeding, and license. Since the workability of the concrete is increasing, obviously the segregation, bleeding, license will also get reduced. We have discussed about this. Next, coming to the point of permeability. Permeability means a penetration of any materials. It may be a water or it may be a chemical. So we all know. I have already told you. You can see this image and itself you can understand. See, this is here you will be having this air bubbles. They are uniformly distributed, right? So what happens? There is no interconnection between these air voids. So the penetration of the chemical from one air bubble to another air bubble is not easily possible. Okay, so that what happens? The permeability, that is the penetrating nature of the water molecule or chemical will be reduced. That is, therefore, it reduces this air entrained concrete will reduce the permeability in the concrete. Okay, so that is what this is also. It is resistant to chemical attack. So I told you previously. In the strength point itself, we discussed that it will reduce the sand content. Okay, so it will reduce the filler material content, but it will increase the cement content to some amount. It also depends on the mixing procedure. Okay, it reduces the unit weight of the concrete. Water content will get reduced. Alkali aggregate, because you think some of the volume of the concrete is occupied by air bubbles. So obviously the cement content, sand content, water content will all get reduced. Okay, unit weight is nothing but it is the weight of the, you know what is meant by unit weight, right? So this is also getting affected because of this air bubbles. Whenever you are adding, incorporating some amount of air into the concrete, the unit weight will get reduced because the concrete is little denser. It is not as denser as the conventional concrete. Okay, so these are all the reason for reduction in the sand content, water content, and unit weight, cement content, and all. So whenever the cement content is reduced, what happens? Obviously, the heat of hydration will be reduced. That is also very clear. So whenever the materials or you are using lesser material, the cost wise also it will be little economical, which means it reduces the cost. That's all. So that alkali aggregate reaction, everything will be affected due to this air entrainment in the concrete. Okay. So we have discussed about this. In addition to this, there is one more point, that is abrasion resistance. Okay, concrete containing less than 6% air entrainment has about same resistance to abrasion as the conventional concrete. Okay, so whenever you are adding air entraining admixtures, if the air entrainment amount of air entrainment in the concrete is less than 6%, means okay, its resistance to abrasion will be same as the conventional concrete. Okay, so this is there is a progressive decrease in the abrasion resistance when you are increasing the air content. Okay, so for example, if you take when you are increasing the air content about 10%, abrasion resistance will be lesser when compared to the conventional concrete. So what they are saying is abrasion resistance and all we will be discussing in the pavement structures. Okay, so we all know what is meant by abrasion. Abrasion means nothing. It is the wear and tear effect of the surface. Okay, it may be any surface. So here we are discussing about the concrete, right? Wear and tear means it shows the durability nature. So you can see in the pavement, so many vehicles are moving, crossing. Okay, so it will cause some wear and tear effect in the concrete surface, in the pavement surface, that is called abrasion. Okay, so the surface should be abrasion resistant, then only it will withstand over the time. The durability of the pavement will not get affected. So to withstand that, the abrasion should be resisted. Okay, right? There is some criteria. One is the amount of air entrained. Okay, the amount of air entrainment should be less than 6%. Then only this abrasion will be lesser. Okay, lesser means the concrete surface will be capable of resisting the abrasion when the amount of air entrainment is less than 6%. So in pavement and all, they will be adopting only up to 6 to 10 percentage in the range. So it will be a satisfactory condition when you are going for the pavement. So that is what they are discussing. Here, this diagram we have discussed. That is one more I repeat, because this is the important mechanism. See, here you are having your crack. Okay, let me explain. Yeah, here you are having your crack. Okay, here you are having some of the air entrained. Okay, these are the air you are entrained by yourself. See, these cracks are interconnected. Okay, these cracks are interconnected. But see, these cracks are interconnected to the air bubbles also. So what is happening? This, whenever some pressure is exerted in this crack, this will be distributed to the air bubbles. But this air bubble is not connected to any other thing, so it will not transfer the pressure throughout the concrete. It will take care of the pressure by itself. Okay, so that is the simple phenomenon adopted in the air entraining concrete. So this is all about the air entraining admixtures using in the air entrained concrete. And also you can see some more images. So this we have discussed. Frost damage or joints of the pavement. So this is on pavement surface, some crack is developed. So here what they here water will get accumulated, and over some temperature, what happens? It forms like a ice. The volume of the ice will be 10% higher than the volume of the water. So it causes volume instability. It will make the concrete to develop more cracks. Okay, the crack region will get enlarged. To overcome these effect and all, we can adopt air entraining admixtures. Okay, say you can see here near the joint and all, they are inducing some amount of cracks. This can also, this is also due to the frost. Okay, so this is also happening due to the lesser temperature variation. See, this is a scale, this concrete surface. Scaling means you can see this in normal road surface itself. Scaling means nothing, the top layer will be getting abraded from the pavement. Okay, this is called a scaling effect. So this is also can be overcome using the air entraining admixtures. So this is all about air entraining admixtures. I hope you understand, and thank you all for watching.